Moving on to the next lecture. It will be given by Professor Sandeep Shukla. Professor Sandeep Shukla is currently Poonam and Prabhu Goyal Chair Professor and ex-head of the Computer Science Department, IIT Kanpur. He is on the Board of Directors of Reserve Bank Information Technology Private Limited and also member of the High-Powered Committee on Cyber Security or SEBI. He is a PhD in computer science from the University of Albany. He has worked on formal methods for system design and other problems related to embedded system design as a postdoctoral research associate at the University of California. So requesting him to please kindly come and deliver the lecture.
Good afternoon. Can you hear me? So good afternoon, everybody. So I am standing between this and your lunch. So I'm going to try to finish things as quickly as possible. So I'm going to talk about potentials of smart contracts in digital India. And the entire idea comes from the National Blockchain Project. It's a project that we have been doing since 2018 under the funding of the National Cybersecurity Coordinator's Office. And the idea was to actually demonstrate some e-governance applications of blockchain technology. And in that process, we developed solutions that went live in Karnataka, and also certain projects that are used in multiple different academic institutions. So I'll talk about that. But before I go into the actual smart contract applications or blockchain applications, I want to say a few things about smart contracts. It's kind of summarizing what you have heard in the last 2 days. So what are smart contracts, right? So yesterday you heard that, and today also from Deepak's presentation, that smart contract is kind of an evolving concept. It's not fully defined yet. But in general, what we understand is that a smart contract is a program that is self-executing, and it's basically or tries to automate certain actions that you would have normally taken in case of abiding by some legal agreements. So for example, if you take a loan and against a collateral, and you have a legal agreement that if you don't pay in certain time, or if your loan amount is above certain fraction of your collateral, then your collateral may be liquidated by the lender, and in case you pay back, then your collateral will be released. So this is the kind of legal agreement that you can put in a program, and then you can basically send the collateral to the contract, and the contract will accordingly pay out the loan to your account. And in case you want to pay back, and then the collateral goes back to you, these kind of things can be easily automated with a smart contract. So smart contract is a self-executing program, and now you might ask that most applications that we do today, for example, we use various kinds of like UPI, for example, GPay, or we do various other kinds of things like buying stuff from Amazon and returning stuff on the website and so on. All these things are actually programs, right? So you are accessing those programs either through an Android application or a web application. And in the back end, as you click on buttons or touch certain events, buttons, then you actually, in the back end, at some server somewhere, some execution happens, right? And that execution changes the state of the program. It changes entries in the database, or exposes certain entries from the database to you and so on. So why are they not smart contracts, right? So why most of the automation we have been seeing in the last 10 years or so, including, for example, Aadhaar, right? So Aadhaar e-verification or things like that. Why are they not smart contracts? Why is it that, what is so special today about smart contracts? So one of the things that is important in the smart contract is that once the smart contract execution is completed, the transactions has to be trackable and irreversible, right? So this is something that distinguishes smart contracts from regular web applications or Android applications and so on, right? So, so let's see, how do you make the program self-executable, right? So, so you need an execution platform. So, for example, in case of a web application, you have a server sitting somewhere, either on the cloud or on a regular server. And in case of a smart contract, we usually do this on a virtual machine. And there has to be an event handling interface, right? So there has to be a way to actually, trigger the executions through some kind of events. It could be a touch of a button, or it could be, making a transaction, things like that. And so there has to be a way for the program to actually wait for events to happen or transactions to come to it, to its interface, and then appropriate functions have to be called. So yesterday, if you were there, you have seen some example on Solidity in the last presentation, where you saw how using Remix the speaker was actually interacting with the smart contract. So he was putting in inputs, either inputs to the smart contract, or he was pressing a button, and certain events were generated, which would actually invoke certain functions that are already written in the smart contract. And then, as Deepak has already discussed in detail, that the execution has to be deterministic. Now, why is the execution needed to be deterministic? Is because smart contract has certain properties which, even though we have not fully defined what smart contracts are as a final definition, since 1996 we have the notion of smart contract, but we haven't fully defined what smart contracts are, but we all have more or less a consensus view of what smart contracts are. So the smart contracts, whatever state change you make by a transaction has to be irreversible, and the state change history must be immutable. So you cannot go back and say that this event didn't happen, or this transaction didn't happen, or this transaction happened in a different way. And the state trajectory has to be trackable, and the information about the state has to be highly available, and highly available so that even if the program crashes, it should be not invisible to the stakeholders. And the information has to be transparent, and state change should be verifiable by anyone, right? So this is what a smart contract requires, and that's why the regular web applications or Android applications that we see today are not called smart contracts. They are regular programs. So smart contracts execution ecosystem, some executions may require authentication, right? So you may have to be a certain person, a certain account holder to execute certain transactions, right? So in many times you do not want any random person to actually execute that particular transaction because it involves movement of tokens or movement of funds, etc. The execution must be deterministic. We have already discussed that. And state must be replicated for high availability. So it has to be replicated. And the public part of the state. So not every information in a smart contract need to be publicly visible, but the important part of the information that depends on the contract and how the contract was designed should be transparently visible. And as I said, the history of the state change must be immutable, and state changes must be verifiable by anyone, right? Now, all that stuff together tells you that I need some kind of an environment in which this smart contracts can execute, and distributed ledger technology or blockchain technology is good, fit for this kind of an execution ecosystem, right? So it's the smart contracts, the idea of smart contracts by itself cannot really exist without having a execution environment in which these properties, that smart contracts are supposed to have can be actually enforced. And this is why smart contracts are usually seen on blockchains or DLTs. So blockchain is usually the smart contract execution environment. So for example, you can the first blockchain that we have seen is the Bitcoin blockchain, right? So in the Bitcoin blockchain, for example, when you actually do transactions, right? So you have multi-sig transactions, right? So where multiple signatures have to be present for that transaction to be valid. Similarly, you have micro payments mechanisms in Bitcoin. So those are also smart contracts, but those are very, very not so parameterized smart contracts. Those are smart contracts that are very, very hardwired into the Bitcoin blockchain ecosystem. So the smart contract that we first saw with the full programmability was in Ethereum, right? So solidity based smart contracts that came in Ethereum that gave you the ability to for users to program various kinds of logics. So multisig or micropayments in Bitcoin were not possible to actually do anything, any variations of that by the users. So by having, although the Bitcoin blockchain has a scripting language, and that scripting language is very, very, it's quite limited in what it can do. Its expressibility is quite limited. Therefore, you couldn't do a whole lot of things with the Bitcoin blockchain scripting language. Whereas in Ethereum, you have the full, what we call Turing complete language. The Solidity is a Turing complete language. And then since then, all the other blockchains that have come up have the ability of, executing programs. And this execution of programs, these programs are written in various other languages such as Golang, and even in, you can now write programs, the smart contracts in Java and JavaScript and various other languages. So blockchain provides an ability to actually replicate the execution across multiple nodes. So not only one node is executing the smart contract, but every other node which wants to create a block, or what we call validating nodes, will actually also execute the program. And that's where the determinism helps, right? Because if the program was non-deterministic, then in one node, it will execute and produce one result. In another node, it will produce a different result. And therefore, the other node will not be able to validate the transactions that was done by one node, or the node that is creating the block. And the state change is a transaction, and these transactions are recorded in the blocks. And state change history, therefore, becomes immutable, because in the blockchain, the transactions in the blocks, once the block has been made and a sufficient number of blocks have been built, the blocks you cannot go back and change the transactions unless you have an immense amount of resources, either computing power or resources in terms of stakes and so on. So any validating node can also execute the program to verify the state change. And the replication of execution provides availability, and anyone with the access to the blocks can track the entire state trajectory, right? So the requirements that I was talking about earlier, blockchain provides that execution environment which allows the smart contracts to have these properties that we want. So as Deepak was earlier saying, that oftentimes he says to a person who wants to do a blockchain project, we often hear this from many organizations, that we want to do something with a blockchain. And then we ask, like, what is your problem? First tell us the problem, and then we would analyze it, and we'll tell you whether a blockchain, smart contract, etc. are required or not, right? So in many cases, a blockchain may not be required. So in many applications, and web application, or some kind of a application based on server, or server running on a cloud is sufficient, right? So it depends on what your assumptions are about your trust model, what your assumptions are about visibility, transparency, and then what are your performance requirements, and many other things, right? But in general, given that we have this digital, there is a whole digitalization of services in India for the last 10 years or so. We have Aadhaar, we have UPI, we have Digi Yatra, we have various other, DigiLocker, various kinds of applications. So the question is, which of these could have used blockchain for various properties that we want out of them? For example, if you look at Aadhaar verification, right? So when we actually go to a bank or some place where we have to do an Aadhaar-based authentication, we give fingerprint or we get an OTP, and based on that, everything happens through multiple different servers. Like, for example, there is a concept of AUA, and there are at least two different servers through which this request goes all the way to the Aadhaar data center where your fingerprint is actually matched or your OTP is matched, and then the corresponding success or failure comes back all the way through these two different intermediaries back to the final bank or wherever you are doing your e-verification, right? Now that is a lot of multiple different steps that it has to go through. That's one thing. But the second problem is that if there was a case where a mobile company, I think it was Airtel, which was actually asking for other authentication at the time of taking your SIM card. And at the same time, what they did was they reran the same authentication and created a bank account, Airtel, some kind of an Airtel bank account. And then since that bank account got connected to Aadhaar, the gas cylinder subsidy of people were being deposited to that bank account, right? So now you do not know how many times people run your e-authentication. In Aadhaar, there is also a demographic lookup that you can do without fingerprint or without the OTP. So how many times organizations are doing demographic lookup of your Aadhaar data? This kind of information initially was totally unavailable, and after some time UIDAI, they actually created a web site, so you can actually log into the UIDAI website and see all that information, right? So this is a completely web-based information. So there is the question of transparency. Are people using my Aadhaar information or looking up my Aadhaar information? I have a right to know because it's my information, and how I can know that information. So UIDAI authority made it available through a web application that if I authenticate myself to them, they will tell me in the last so many months who looked up my Aadhaar information. But the question is that what if they actually omitted some of the lookups, right? It's maybe they're doing, somebody is doing surveillance on me, and somebody looked up that information, and I am not being shown that. So there is this notion of trust. Do I trust the servers or the programs that are showing me all this data over the web application? So a blockchain solution, a smart contract-based solution would actually make this thing much more transparent, right? And the public trust on the system would actually will be enhanced, because now I know that this is immutable. Nobody can hide some of these transactions. The transactions that were done on my personal information was done. Nobody can actually hide that information because it is put in an immutable state through the blockchain technology, right? So this is the kind of places where the question that the application developer should ask is, what is the trust requirements, right? If I feel that everybody trusts me and there is a public trust in the government service or the service of a particular company, then they can actually run put that system on the web application or a server, and there is no need for a blockchain. But if there is a belief, there is a reason to believe that there would be doubts, then it is better to come out and create a transparent system. So transparency and trustless system design is one reason why you would want to go into a smart contract and blockchain environment rather than a server-based environment. The other issue is that when we do UPI, for example, so in the UPI, whenever you actually initiate a payment on UPI, first the virtual address your virtual address has to be translated, and there would be a bank through which this virtual address was created. So it first goes to that bank. Then it goes to your the account. The account is maybe in another bank. Then it has to go to the again the UPI servers, and then it has to go through the receiving bank. And so there are multiple different intermediaries interposed in one transaction of UPI. So even if you are making a 50 rupees transaction, it goes through at least, I think, about four different intermediaries. Now, this is what we call friction in a payment system. So there is a friction in the payment system, and if one of these intermediaries fail to function, then the entire process will fail. So if we want to reduce friction, for example, then also if this entire thing was based on smart contracts and blockchain environment, this friction can be reduced. So in many cases, we do this for trust. In some cases, we do it to have transparency. In some cases, we do this for frictionless delivery of service. And in some cases, we do this for, trustless, create a trustless interaction, right? For example, in procurement system, for example, so we have multiple different parties involved. And these multiple different parties keep all their data in silos. And every time that we want to have a full visibility of the status of what is happening, then in that case, we have to basically go across these different silos. And that is difficult because of these organizations have no reason to trust each other. So therefore, they do not necessarily will give access to APIs to each other's servers, so that all that information can be actually fetched from all these different servers that are owned by different organizations. So they have to come together into some kind of a enterprise agreement between these organizations, and then create a way to actually share this information that is relevant to all the parties. And that is where this blockchain technology will be useful. So therefore, so web applications has sufficed so far in the Indian digitalization journey. We have had very good, successful, actually, Indian payment system is probably one of the best in the world in a digital payment system. Even now Singapore, I believe France, they are actually wanting the UPI technology. We have done well with our ID system, although it's a centralized ID system, but it is also one of the major ID systems in the world. We have done DigiLocker. We have done various other types of digitalization. The question lingers is that whether you want better way of information sharing with much real-time access to information across various silos, whether we want transparency across multiple silos as well as transparency to the citizens, if we want more trustworthiness with respect to the various services we provide through digitalization, and all that stuff, if we consider the various services, and if we look into these questions, then we'll be seeing whether we need this smart contract and blockchain-based solutions, or we can still do with, and now everybody is going to cloud. For example, many of the applications now are being put in cloud. So this kind of answers we have to actually get in order to know where to go. So now switching gear from that, I'm going to say a little bit about the multiple different projects that we have done from our national blockchain project. So I'll talk about, I'll talk a little bit about each of these. One is about the land registry in Karnataka that we have done, and then an advanced e-procurement system that we have done in Karnataka as well, and verifiable credentials via self-sovereign identity. And then right now we are doing one for the Kanpur Development Authority, is the transferable development rights management. So now, as you will see that this entire, end-to-end business process is not implemented on blockchain. Certain parts of the system is implemented on the blockchain because of this issue of trust and because of this issue of transparency. So these are the Kaveri blockchain project is the name of the land record registry project that we finished in 2021, and it was used in 6 districts. After 6 districts, it was live. The head of the e-governance in Karnataka retired, and since then it is still in 6 districts and not in all 70 districts. There is a blockchain-based e-procurement integration project we have done, which is also for Karnataka e-governance department, which is live right now. The self-sovereign identity project, and we have given degrees at various institutes using the self-sovereign identity mechanism that has been used by multiple different organizations. And then currently we are doing this TDR project, the transferable digital rights, which is being developed right now. So in all of these cases, we are using permission blockchain. Actually, we are doing Hyperledger, and the Hyperledger fabric, basically. And the idea is that we have actually, in this Kaveri blockchain case, we have 5 different nodes, the consensus nodes, that are actually distributed across multiple different government organizations. Now you might and blockchain purists will not consider it as a distributed ledger technology, because they will say that this is all, the government departments, so they can collude with each other and actually change the entire ledger. But here the trust is relative concept, right? So the reason why the head of the e-governance actually approached this problem with blockchain is because there has been multiple cases in the courts in Karnataka where land records of multiple different people had different owners than the original owner, which was done apparently in the back-end server. The server was maintained in the land registry office, and apparently things were changed. So he wanted something to be actually more immutable. So having put this in multiple different government departments, it was assumed that there is not enough collusion across these various departments to actually do this. Now you can actually, depending on your assumption of trust, you may have to distribute it to a much bigger set of organizations than just 5 of these organizations. But the idea was that not everything was like, for example, the actual deeds were not put in the blockchain, but the proof of transactions that you are doing on the transfer of rights or transfer of lands, that information was being put on the blockchain. So this information and the proof of consent, that the user consented, this was done through eKYC, through Aadhaar, and then we actually created a smart card in which the private key of the user was embedded, and the user was given that card, and then through that card they can prove their identity and then also record their consent. So this information was only on the blockchain, not the entire land record or the deeds. So you can see pictures of the first day of actually opening this. So here this person is actually holding a card, that smart card that we have created. It's a Kaveri smart card. And second project that we have done for the Karnataka e-governance department was an e-procurement integration platform. Here also the actual functionality that was put on blockchain is very simple. The idea was that different states have their own different e-procurement systems. And various vendors and suppliers, they appear as different entities in the different states. So therefore, if a particular entity has a certain issues with for delivering things on a particular state, the state of Karnataka wouldn't know, and then accordingly they would actually award this maybe the tender to that particular organization, and that could create problems. So therefore, this was actually an information silo, integration of silos, data silos across multiple different states. And this was again done on a permission blockchain. Again, it was done with the Hyperledger Fabric. And it was actually working as a national deduplicated supplier data store with award of contract and work experience certificates linked to supplier identity. So this was, this onboarded Telangana, Andhra Pradesh, Chhattisgarh and Assam e-procurement systems, and various banks were also onboarded into the network. So that was the e-procurement case. The next one is the transferable development rights project that we are currently doing. So here the idea is that if the town for planning purposes or the city for planning purposes procure your land, then instead of paying money, they can give you development rights, and initially that was being given as some kind of a physical certificate. And then you can actually transfer that development right to somebody else and get money. You can also fractionalize the development right and give to multiple people. So this project is being done by implementing a token system. This is being done on Quorum blockchain system, and this is actually by creating a tokenization of the development right. And this token, through the smart contract, we can actually fractionalize the ownership of the token, and this is currently undergoing. The work is currently undergoing and supposed to finish next month. So this will help create a marketplace for development rights. So you can actually go to the marketplace and sell the development right that you have received from the government. So it is integrated with the building plan approval portal. It has certain other advantages. We have created a wallet, and we have Aadhaar-based identification, and you can trace the ownership rights over time through the immutability of the ledger, and there is a non-repudiable consent through Aadhaar KYC. So the last thing that we have done, not the last thing, but this is the another thing we have done is the creating a self-sovereign identity system using the blockchain technology. So here, the idea is that instead of having a identity in a server somewhere, like in Aadhaar data center, your identity information is all on the Aadhaar data center, and all the information is under the control of this authority, and the user has no, other than the legal provisions that protects the user rights, there is no technological provision for user to actually have sovereignty over his or her own individual data, right? So the authorities can actually use that data any way they want, access or give access to that data any way they want. So that is, as opposed to that, self-sovereign identity is when the user has, only the user has the access to the data, and the authority that issues the identity does not keep the data for itself. And but there are cryptographic techniques by which the fact that the issuer of the identity, the legal issuer of the identity, has issued that identity can be established by cryptographic digital signature verification. Also, user can actually decide who to share the identity information with and who not to share the identity information with, and the also amount of data that they want to share. For example, if I want to prove that I am above 18 or I am above 65, I do not need to give my father's name or my address or my exact date of birth. I have to be able to prove cryptographically using zero knowledge proof to the verifier that I am above 18 or above 65, whatever I want to establish, without giving out any more data. Right now, if you want to prove your age, you have to show your Aadhaar card or some other document, driving license, where your birth date is, and much more information than just your age will be revealed to the other party, right? So this is what is called selective disclosure. So we can do selective disclosure also with this self-sovereign identity mechanism. So this is what we want to create. So, and this is what is, this is actually a W3C standard called verifiable credentials. So you can actually create verifiable credentials for any kind of identity data. And then you can actually hold this verifiable credential in a digital wallet, and this digital wallet can communicate with another digital wallet to actually provide any kind of information that they want to provide using NFC or Bluetooth or whatever local technology is required. They do not need to go to any server to actually prove their identity or share their identity like we do currently in DigiLocker. So this is the idea. So this is how we have developed this. So we have a permissioned blockchain. This is again actually Hyperledger Fabric, but it is publicly accessible in the sense that there is read access by the public, but not write access. Write access is only given to certain organizations which issue identity. So let's say you are an issuer, and so let's say you are the PAN card authority. So what you would do is that your identity has a schema, right? So you have a schema of the identity, so you actually registered the schema, because anybody who wants to interpret the data that is being shared as your PAN card information needs to know the schema of the PAN card. And then you also registered the public key of the issuer on the blockchain. So the blockchain here is actually being used as an information sharing conduit or information sharing platform that allows everybody to register their public key and make sure that this public key is not tampered with. So that's the immutability property of the blockchain is being used. And now the issuer will now create the credential, let's say in this case PAN card, and the holder can actually request the issuer about for issuing the credential, and the issuer will issue the credential to the holder's wallet. Now let's say the holder needs to go to a verifier. The verifier, let's say, wants to verify his PAN card. So verifier has to now, once he obtains the data from the in the verifiable credential DID, what we call data identity definition schema. So then verifier will actually look at the issuer and go to this blockchain and check the schema and the public key of the issuer. And once he has the public key of the issuer and the schema, he can interpret the data and also check the signature on the information. If the signature checks out, then this is not only issued by the issuer, claimed issuer, but also data has not been tampered with, right? So the tampering data is since the issue of the document, no tampering has happened. Now, this kind of thing actually can also happen in something like DigiLocker, right? So in the DigiLocker, what happens is that you go and you go to the server, and the server redirects you to the issuer, and the issuer has the PDF of the document, and the document is digitally signed. So you can still check the digital signature of the document and make sure that this is actually valid and the PDF has not been tampered with. The difference is that in this case, the data still resides at the issuer, and the issuer, basically the holder of the degree or the credential actually instructs the or consents to for that data to be shared to a verifier, and the verifier receives the entire document. And the verifier, so there is no selective disclosure. The user, the holder of the credential will not be able to decide which part of the information he wants to share with the verifier. And there is no zero knowledge proof. So certain information such as age and other things, or the location, district-wise location, etc., cannot be proved without giving out the entire information about the user. So here is a sample journey of this kind of a self-sovereign identity. So let's say there is this girl called Vidya, and she has the digital wallet. So this digital wallet you can get actually from the Google Play Store or from the Apple App Store. It's called Indici wallet. So this wallet you can get, and then you can go to the other authority. Now, other authority has not implemented it yet, so you cannot get it from other authority right now. But we are trying to convince them. So you apply for your Aadhaar. So at this point, you will do a eKYC. So we are bootstrapping of Aadhaar. In the absence of something like an Aadhaar in a country, we have to do something different. We have to get, from the driving license authority, or somebody has to be onboarded to this system. But since India has already Aadhaar, so you can actually get this from Aadhaar, and Aadhaar authority sends the verifiable credential to Vidya's wallet. And then Vidya goes to IIT Kanpur. So she's a student of IIT Kanpur, just graduated. So she goes to IIT Kanpur and apply for a degree. So now IIT Kanpur has to first figure out if Vidya was a student there and graduated. And also they have to decide whether it is indeed Vidya who is asking for it. So they will use the other the other credentials. They don't have to do an additional eKYC. They can use Vidya's other credential and can verify that it is Vidya, and the rest of the verification they have to do from their data, and they can actually give a degree to her wallet. And then she goes and applies for a job. So here, let's say she goes to a company, and the company wants to first establish that it is she is indeed a bona fide person, and also that she has a degree, a requisite degree. So then they right now she has two credentials in her wallet. So she shares those two credentials to the job portal, and prove her identity and degree, and receive and in case she gets a job, she gets a job certificate, which is also given in terms of a verifiable credential on her wallet. And then finally she applies for let's say goes to the bank to apply for a credit card. So then she has to prove identity, address, and income. Now the income is already embedded in the job certificate. So now the bank can verify it instantly. So this will make things instantaneous, right? So the first identity establishment of her wallet is the key, right? So it can be done through Aadhaar, or it can be done through in-person verification. Like right now, the way the degrees are given through IIT Kanpur right now, we don't have the Aadhaar credential yet. So we do this through the Dean of Students office, through the in-person verification. So so far the various universities have given degrees on our system. For example, IIT Kanpur has done 2 convocations. Indira Gandhi Open University has done once. The UP Technology University, AKTU, they have done once. The NIT Rourkela has done twice. IIT Indore has done once. And then currently also the National Skill Development Corporation, they are planning to give their training certificates through this mechanism. So the various things that are involved in developing this ecosystem, you need a digital wallet or some kind of a digital, some kind of a application where the actual credentials will be stored, cryptographically encrypted, and so on. It has a selective disclosure feature. You can selectively disclose certain information, because each piece of information in the DID are actually digitally signed. So it's not like an entire document is digitally signed, but every piece of information is digitally separately signed. Proofs cannot be transferred. So if you prove your identity, it cannot be transferred. So right now, if you give PDF to somebody, they can send it to somebody else by making some surgery on the PDF, etc. This is not possible here because of the digital signatures. Zero knowledge proof can actually be used for proving certain predicates about your identity. It has multi-credential proof, so you can actually use parts of various credentials to create a proof. Interoperability and secure and private channels to send the information from holder to verifier. And it has also a few other things that are enabled through this. For example, autofilling of web forms using your verifiable credential information with your consent, passwordless login, various other activities can be supported through this. So I think that's all I have. So what? Let me summarize this. So in the National Blockchain Project, we have been trying to show by actually going to the real government departments and real government business cases that certain aspects of your certain digitalized services can be actually made better, more transparent, more trustworthy, and more, information, the frictionless by using the blockchain technology. And so we have picked up, well, we didn't pick up necessarily on our own, but certain opportunities came to us, like the land registry came to us from the Karnataka government, and through that the procurement issue came in. But overall, our experience is that since India is going, at a very rapid rate to providing digitalized services to citizens in many different aspects of government services, it is, and there are issues with respect to friction, with respect to too many intermediaries involved, with respect to various kinds of trust issues or transparency issues. So there are various ways that certain aspects, not necessarily the entire end-to-end business process, can be put into a blockchain-based solution, but certain aspects, selected aspects of the problem can be actually solved using blockchain and provide these properties of transparency, trust, low friction, and the reducing the intermediation. So I'll stop here and take questions if there are any. Yes.
Good afternoon, sir. It is nice to hear you here. I want to ask question about Hyperledger Fabric and land registry. If you are going through the IoT devices for geolocation based land